Right, we're ready to go. Okay, we've got a lot to get through, so I think we'll make a start now. Just a couple of housekeeping things for those of you who are online. Please keep your mics off. It's very difficult if somebody leaves an open mic to chase it down. And the other thing is please try not to use the comment section of your of Zoom. You will be getting a feedback form later, which you can use for comments and feedback. Okay, so for those of you who don't know me, which let's face it, it's probably most of you, if not all of you. My name is Martin Robinson. I'm a retired hydrogeologist, registered professional geoscientist. I've worked in research, government, and the private sector, mostly in corporate consulting. I've been a member of the ARG for 25 years, about 15 years of which was on federal council, during which time I had several roles, including membership director, vice president, president. I've also been a member of a bunch of standing committees, including the Professional Registration Committee. And over the last 8 to 10 years or so, as a member of the Education Subcommittee. And it's in that capacity that I'd like to, that I'm here today, and I'd like to welcome you all to the webinar, to thank you for joining us, and in particular to thank all the speakers in advance for their presentations and contributions. Hopefully you will have read a bit about the background behind today's webinar, so I won't go into too much of that. It has been emailed around and it's also on the ARG website. What I might try and do is provide a little bit of a framework. Since its inception, the Education Committee has run a number of activities and programs in this geoscience education space. And over the past year, the committee's been doing some strategic planning. And during this process, one of our key goals was redefined as supporting and fostering geoscience in Australia. The underlying objective of that goal is obviously to increase the quality and quantity of geoscientists entering the workforce. And the next stage of this process will be to develop a 5-year action plan to meet this goal. A couple of points about this type of planning. The first, and this is probably obvious, is that we have access to limited resources. In fact, any organisation, public or private, going through a strategic planning process has this issue. What it means is that we have to focus our 5-year action plan on activities that will give us the greatest bang for our buck, give us the greatest impact. The second thing is that although there are many organisations and passionate individuals involved in the general education space, in the geoscience education space, there doesn't really seem to be a broad knowledge of what activities are being undertaken, by whom, what's working, what's not, what's been tried, and what overlaps or gaps there are between what different people and organisations are doing. And finally, there doesn't seem to be a good common understanding of the trends and, more importantly, the drivers behind those trends in geoscience education, which are used, or at least which should be used, to identify activities. In fact, most observations and interpretations of trends and drivers seem to be anecdotal, based on personal communications, fragmentary and undocumented. And the significance of the last 2 points is that our 5-year action plan can only be as good as the veracity of the input information we use to develop the plan. And that'll be no surprise to any of you who've been involved in numerical modelling and mathematical simulations. The old adage, junk in, junk out, applies equally to strategic planning as it does to mathematical modelling. So that's really where today's webinar comes in. You all have an interest in geoscience education, or let's face it, you wouldn't be here. And so it's our hope that this webinar will do several things. It'll get everybody on the same page. It'll fill in some important gaps that'll help us to develop a focused, practical and pragmatic action plan to support and foster geoscience education in Australia. And finally, if you are directly involved in geoscience education, hopefully the webinar will be useful to you in establishing contacts, and the information coming out of the webinar will be useful in helping you to develop your own initiatives and actions in this geoscience education space. This is pretty much new territory, if not for Australia, certainly for the ARG. It's the first time, at least to my knowledge, that anybody has tried to understand, define and document the relationships between the drivers behind a progression in education that really starts with a school curriculum is filtered through a career guidance process, and that may be formal, as in a school guidance council, or maybe informal, as in the opinions, often uninformed opinions, of family, friends, and the broader community, which then progresses to subject selection in the final 2 years of high school, which then will influence the degree a person can take, which then influences a person's graduate degree if they go that far, and ultimately ends with employment as a professional geoscientist. In actual fact, that's not the end, because as a professional geoscientist, there should be an ongoing commitment to staying up to date with the latest technology and developments in the industry, by which I mean CPD, continued professional development. So that's a very big, broad brush painting of background behind the webinar and some of the outcomes we hope to achieve. And if you are aware of or think this is not the first time that this type of activity has been undertaken specifically for geoscience, not necessarily in Australia, but anywhere in the world, please let us know, because we will chase up that information and add it to what comes out of this webinar. Several members of the Education Committee will be giving presentations today, and I'm sure that they'll provide additional context and relevant background as they go. On top of that, Ned Howard, who's a member of the Education Subcommittee, who will be presenting, will wrap up today's session and talk a little bit about where to from here. In the meantime, welcome. Thank you for joining us. And I'm going to hand you over to Mark Berry, who will be chairing the webinar for the rest of the day. Okay, Mark, over to you.
Excellent. Thank you very much, Martin, for that fantastic welcome. I'd like to also just welcome all of the attendees that we have online today, wherever you might be in the world and whatever time it is. We know we have quite a few international attendees as well. We have a very packed session today, 14 presentations covering 4 themes. Unfortunately, there is really no time for questions and answers, but everyone that's been registered will receive a feedback form. So please use that form to provide valuable feedback to the committee. So I really appreciate that. I will be giving all of the speakers a 2-minute warning, just to let you know, because we've got 10 minutes each session. And we will also, for those attending, we will have a 15-minute break just a bit over halfway through the session today, just so that you can stretch your legs. Without further ado, I'd like to get started. The first session today is all around setting the scene, where we are now, and we have 4 presentations. The first presentation is actually a pre-recorded presentation by Professor David Cohen. He's Emeritus Professor at the University of New South Wales and a past president of the Australian Geoscience Council. So please, Kayleen, if you can make, Lynn, if you can start the presentation now. Thank you.
To help support discussions on encouraging the next generation into the geosciences, I highlight some of the key observations in the AgTep surveys that have been conducted over the last 20 years. The link to the most recent report is shown here, but you can just head to the AGC website. We have longitudinal data on various university metrics from 2003 onwards. Ian Powell ran the first 2 surveys, and I've run the last 2 and probably the next. But assembling the data is not straightforward. Obtaining and cleaning up errors or uncertainties in the data took me 6 months last time. Some institutions do not maintain databases where the information we desire is easily extracted. And we've been faced by questions such as, what is a geosciences student? Who do you include in the survey? Who do you not include? Is an environmental science student with a geology major a geoscientist? Is a student studying climate systems focusing on ocean physics a geoscientist? Hence, I would describe the data set that we've put together as being reasonably indicative, but not necessarily completely authoritative. This is the data. It's assembled individually for all 20 universities with geoscience programs. That information we have kept confidential for various reasons. But what we have presented in the reports is the total data set for the country and the data divided into or combined for resource intensive and resource non-intensive states. So it is a fairly substantial database over a reasonable amount of time. Enough background, let's get into the results. The resource non-intensive states, which is basically the eastern seaboard minus Queensland, has been on a roller coaster ride for the last 20 years, but nothing like our colleagues in the resource-intensive states. Maintaining programs, staffing and infrastructure in such an environment is difficult. But we are not the only countries on the roller coaster ride. We are pretty much in lockstep with the North Americans. But we are progressively cycling up, which is good news. But this largely links to increase in population. If we look at the Europeans, exemplified by the UK, they are also showing cyclicity, but overall with a very steep decline in the number of geoscience enrolments. Much of Europe and a few other parts of the world are in serious trouble in terms of the geosciences. But why is there cyclicity in enrolments? In 2017, with that first report, I was convinced that the cyclicity was controlled by the mineral cycle. And we see, with a 2-year lag, the peak in mineral exploration expenditure, and a couple of years later with petroleum, linked to the peak in geoscience enrolments. But the recent substantial upturn in mineral exploration expenditure has not been matched by an increase in the national undergraduate taught load. An interesting observation is that the total enrolments are dominated by the urban states. It never drops below 50% of total geoscience enrolments. And when the enrolments are down, the urban states can account for in excess of 65% of total geoscience enrolments. I think this is a function of the sheer volume of science students in Melbourne and Sydney, whose universities probably account for 75% or more of the national enrolments in the sciences. I do have a little bit of data on the last 3 years. There has been a significant increase in first-year numbers, but especially in the urban states. I haven't identified the actual universities, but I can indicate that NSW1 is the University of New South Wales. Their first-year enrolments are reaching record levels. But I know the staff have not been undertaking marketing to high schools, and there have been no structural changes to the science or the advanced science programs. Hence, what is behind this significant increase in enrolments at this stage is unclear. We will talk to the first-year students this term to get some understanding of why such a large number are starting to move into the geosciences. We've also been tracking student progression through geoscience programs, but it is complicated by the structure of many science degrees. Very few students enroll in geology degrees. The majority are enrolled in general science programs and may elect to complete a geoscience major, sometimes during their first year, at the end of first year, but in many cases, students do not declare a major until the end of their second year. The inter-year progression is not linear. Most of our programs are anastomosing rather than deterministic, in that there are many paths that can be taken to go through a science program. So what I did is take the enrolments in year 1, compared them with year 2 with a 1-year lag, year 3 with a 2-year lag, and honours with a 3-year lag. Now, there's a reasonably close pattern correlation between first year and second year, but it starts to become much fuzzier when you get into third year and then into honours. With a moderate degree of uncertainty, and given the very different budgetary models that exist across the university sector, I'm still willing to say that with a possibility of 3 exceptions, geology exists because of cross subsidies. The way I've made this determination is to have some estimates about the cost of maintaining geoscience programs, the cost of appointing and maintaining the staff, in terms of the typical income that comes in for a science student and the reported staffing numbers. So there are just 3 universities where the coursework plus HDRs hits that purple line. I would note that 3 of the green dots that tend towards the northwest end of this diagram, they have closed their geoscience programs in the last few years. Now, some might say, well, why should the amount of funding determine whether geology exists? Well, for most universities, geology exists because of cross subsidies from other science schools into the geoscience schools. But that's not unusual. Science is heavily cross-subsidised by disciplines such as business. Research is heavily cross-subsidised by teaching income. High university rankings, large business schools, and massive international student numbers bring in the cash. That can determine whether geology survives. Even if geology is essential for this country, and I don't disagree, geology is very essential, especially given the sources of our foreign income. But if students will not take geology, then what argument can we put to university administrators for preserving geology programs? You certainly need geoscience departments to produce geoscience graduates, but it might be argued there's little point in mounting geoscience programs if there is little demand. Many are still convinced that the solution lies in engagement with high schools. Now, I don't disagree that we should engage with high schools for many reasons, not the least just to increase awareness of the geosciences in the general populace. That, I think, is quite important to the future of our discipline. But there is no correlation that I can determine between enrolments in earth and environmental science courses in high school and subsequent enrolments at university. And I've looked specifically at UNSW and Curtin in this diagram. I reiterate comments I've made previously. Enrolments in geoscience majors is largely dependent upon the overall enrolment in science programs in a given university. What we need to be doing in the university sector is removing barriers to students being able to take level 1 geoscience, have the geoscience more prominent in suggested programs, but also the quality of the first year experience. Between those factors, that is what will generate the number of students going into upper level geosciences and preferably to a full geoscience major.
Lynn, has it frozen?
I think that's it, Mark. That's where it finishes.
Oh, okay. Excellent. Yes, very sudden finish there. So thank you for that presentation, David, and setting the scene. I'd like to introduce our second speaker, which is Doug Young from the AIG Education Committee. And Doug is going to talk about changes to Australian geoscience degrees. So when you're ready, Doug, thank you.
Sorry, Mark, can you see my screen there? I can do it.
All good. All good.
Okay. Okay, good morning, everybody. My name is Doug Young. I've got a similar background in the AIG to Martin, and I've been involved in the Education Subcommittee for over a dozen years, and primarily responsible for the 2 reviews of the university courses which we've carried out. This is a similar slide to one that David Cohen has just shown us. This one comes from David Elmo in the UBC, and it's interesting because it spans the 3 cycles over 50 years, which I've been involved in the industry. I've highlighted the Australian data in yellow. David Elmo also links the downturn in enrolments as a lag effect to cyclical events, which he attributes to booms in the petroleum and mineral sector, as did David Cohen. I don't want to dwell on this cyclicity, but just to principally look at this period over the last 5 years from 2019 to today. So the Australian response to this cyclicity in terms of the universities has been fairly broad, but it's mostly involved redundancies, reductions, and cutting of schools, as we know. The push factors are clearly the undergraduate enrolments and reduced government funding, but more recently the caps on foreign student numbers, which don't necessarily reflect in geoscience, but as David said, cross-funding from business schools will have an effect. The outcomes are departmental closures, mergers, course cuts and reductions in courses, which lead to staff reductions and redundancies. These have particularly affected low enrolment specialist subjects, such as geophysics, engineering, geology, hydrogeology. And it's also led these specialties to become geoscience outliers within other departments, such as engineering or physics departments. It's an international problem. As you can see, it has been occurring in other countries, such as New Zealand, Vermont, Western Oregon, and Laurentian over the same time period. So there's nothing new here. We're all going through the same issues. The AIG first highlighted the problem in 2019 and 2020. The president at the time of the AIG was Andrew Waltho, and he wrote an article for the AIG News, which was carried widely by the news outlets around the country. In particular, he highlighted 2 problems: the ageing geoscience community, which we're all aware of, and then more importantly for today, the move away from a traditional geoscience course structure and content towards broader-based subjects with less geoscientific input. This led to the first undergraduate course review by the AIG in 2020, and subsequently to the definition of minimum core unit requirements as a standard for AIG membership. So these are the activities that the AIG has carried out over this period in attempting to respond to these issues. Andrew's article in the AIG News was followed immediately by the first undergraduate course review, which I undertook, and the setting of the minimum core standards. But that's been followed by several events which have been convened by AIG people and with AIG involvement in other session periods. And ultimately, it led to the second undergraduate course review in 2024 and subsequent removing of those conditions for membership by the AIG. The conditions for membership, which we set in 2020, were a minimum geoscience subject content of 33% of core subjects, which we've listed there, and at least 4 of those at level 2, at that second year level. The second undergraduate course review, which we've completed earlier last year, we've looked at found 30 geoscience degrees identified at 18 universities. This is down from 19 in 2020. And a postscript to that is that with Wollongong disappearing off the face of the earth, it's now down to 17. There are 426 units which we reviewed from a possible 627, of which 207 were compulsory and 207 were core alternative. In other words, X units must be completed from a list of Y units. Most of these units could be categorized into our categories. However, 23% of them could be assigned to more than one category. So there is obviously some scattering and blending of courses starting to occur. The two reviews which we carried out did not allow any statistical comparison to be made, but definite trends were noted. So I've cut the trends into two, and the changes observed, particularly at the higher level, were the blending of earth science schools. Many of the earth science schools are being amalgamated and broadened into more general schools encompassing environmental science, atmospheric science, and climate science, with a resulting change of school names, such as the School of Geography, Earth and Atmospheric Science at Melbourne and Bees at UNSW. The trend is particularly obvious in the capital city-based universities on the mainland eastern states, but not as apparent in the resource states of WA. And as David Cohen said, that is where 50% of geoscience students are originating, so it is going to be an important trend. The second level of changes observed is the blending of subject matters. There's an increase of blending of courses and subjects away from the traditional geoscience subjects, leading to a more holistic approach. The subjects generally contain less geoscience content, often blending geoscience subjects with other disciplines. The most obvious of that is what was formerly known as Geology 1 now becomes something like Earth Systems or Earth and Planetary Evolution, and contains elements of biology and all sorts of other sciences. The subjects are less bound by traditional subject titles and themes, and may cover areas which overlap in geoscience content as well as traversing outside of geoscience. An example of this might be tectonics and igneous petrology, which, when combined, becomes the study of plate tectonics and the intrusive environments that develop as a result. This combination of geological or traditional geological subjects means that there is less content of each of the subjects within the unit. It also means that the subject boundaries that are becoming less well defined, and the AIG's review has found that this has become a major problem in defining what is a geoscientist, which is the question David Cohen originally asked. So the AIG's response to the second survey in May 2024 was to remove the 2020 requirement for a minimum core subject list as a requirement for membership, and considering that it was now too difficult to clearly define and categorise the subjects. So overall, our conclusions is it is becoming increasingly difficult to define a geoscience graduate, and I think that's exactly what David Cohen said earlier. Watering down of geoscience knowledge is occurring in many subjects. There's a general lower standard of geoscience graduates coming out of university, and less science graduates have geoscience-ready qualifications. For students, there is no clear path for geoscience education, and that results in decreasing geoscience academic numbers and increasing academic outliers. Thank you.
Excellent. Thank you very much, Doug. Really appreciate that. Our next presentation is by Professor Greg Webb, who's from the University of Queensland, and Greg's going to talk through university drivers. So over to you, Greg.
Thank you very much. Is the screen up?
Yes.
Beautiful. Well, thanks very much for having me and following on from both David and Doug. I'm going to talk about the university drivers of geoscience. First, I would like to pay my respects and acknowledge the traditional owners of the lands upon which we speak. In my case, that's the Yugara Turrbal people. But I want to talk about who's driving this geoscience bus from a university perspective. And so I want to talk to you from the coalface, as it were. And so is it geoscience academics? And there's one I prepared earlier. We are active in this space in helping design and develop curricula. This is the AGC curriculum put forth in 2015, I think. And we do that. We're also responsible for designing and developing the syllabi for our courses. Okay, and so nobody tells me what to teach in stratigraphy or whatever. And so there's a tick there. And then there's to determine if our courses are taught or something like that. Well, actually, I don't have any say in that at all. So the decision for whether, say, stratigraphy is taught at university generally comes from management up in that ivory tower there. So that's a tick for those guys. But of course, are they the driver? Okay. The problem with this is that course and program offerings are entirely economic decisions. And of course, we know that universities are largely funded from Canberra. So maybe we have to talk about what's going on there. Well, the Commonwealth Government Grant Scheme is what funds the Commonwealth supported places, which are individual students taking degree programs. And basically, this sort of funding comes in clusters where the sciences and engineering and some different things make about $28,000 per student. And that includes that Commonwealth Grant Scheme, but also the HECS, or what they call HELP now. The thing that's important to remember is that there's no requirement for universities to teach any of these particular sciences or subjects. There's no mandate. There's nobody in Canberra who says, okay, you must teach geology, you must teach mining engineering or anything like that. It's been left to the free market, and therefore it's basically all controlled by bums on seats. And we know this before. There's nothing new about this. It's what is the student demand that determines whether you get taught or not. So we know this Economics 101 very well. I've been involved with talking to industry about this for many years, largely with PISA and so forth, but also with AIG. We know that earth sciences is expensive to teach. Laboratories, microscopes, computers, it's all expensive, and field work, which is critical for us in teaching, it's expensive. Of course, as David mentioned, salaries are a huge proportion of budgets. And if you want expertise, you want a mineralogist, tectonic guys, structural guys, geophysicists, they have to have salaries at these departments. And universities are actually cash strapped. They're not just complaining. There isn't a lot of money. And remember, there's no requirement for universities to teach a particular science. So expensive things have to be cross-subsidized a bit, but economics sometimes suggests, well, why don't we just ditch it? And we've seen that happen. So bear in mind, universities are not driving this kind of stuff. They're reactors. They react to demand, and that determines what we teach. So what determines the bums on seats then? I think this is kind of critical to us. How about industry? Well, gosh, geology is great to study. It's fascinating. It's incredible. We all know and love, the earth. Geology salaries are great. Okay. There's huge social demand for geology. You can feel good about what you do because we need this stuff. Okay. So what is the problem? Well, it's already been acknowledged boom and bust is a problem for us. Traditionally, demand for minerals goes up, investment goes up, jobs go up, student numbers go up with a little bit of a lag, et cetera. But the same thing happens with booms. People are let off. You hear about geologists driving cabs, blah, blah, blah. It seems like you hear a lot more about that in relation. But of course, there is a ratchet effect. And so I borrowed this from health, and so notice this is pain flare-ups. For this talk, this is maybe student numbers, or more importantly, staffing in universities. We know that numbers go up, you're doing great, then you have a little bit of a downturn, such and such retires, and you don't replace them because you're in a downturn. Next time, it doesn't go up to as good as staffing. So university staffing and entire fields of expertise tend to be lost in this sort of a downward ratchet. And the final thing at the end of that from universities is you close whole programs. And so this is just an economic sort of thing. But of course, you know, critical minerals, the federal government has said, critical minerals are one of our key strategic things. Everyone hears about this. What about that? Well, guess who's driving bums on seats? In my opinion, I think it's got a lot to do with social media and the mob. We got guys like this who scream the loudest, get the most headline space, and so forth. And God love them, I think their hearts are in the right place, at least most of them. There's some anarchists and crazy folk out there too, but I mean, most of these people think they're saving the planet. They're just poorly informed. So, you know, you can say, hey, environment, we've got environmental geoscientists, geologists do all this kind of stuff. But let me tell you, these guys know best. They don't necessarily need to be educated. And of course, there's resources. Forgot to turn the light on. It brings up one of my favorite jokes. How many miners does it take to change a light bulb? Well, back in the days of these incandescent bulbs, it took 13 different kinds of miners to make this. But of course, we've got all this new technology, AI, surely it isn't that bad anymore. Well, you know, these days, LED lights might require 18 different mine products. Okay, so resource needs are not going away. What do our drivers say to this? They say no. This is a sand mining protest in New Zealand, and you just have to ask yourself, how many people rode to that on their fancy titanium bicycles so as not to use fossil fuels? It's a problem. So they want us to say no to planes, trains, and automobiles. That's not the movie, by the way, which was okay. Bicycles, computers, mobile phones, and don't forget that full-on half of all nitrogenous modern agricultural fertilizer is made through Fischer-Tropsch from natural gas. But we need to give all that up. Do they understand that? I guess this slide kind of sums that up a little bit. So they don't want to hear it. Okay. I do like this slide. Anyway, I think the solution for us, and this has kind of been mentioned already by David and Doug, public perception is really maybe the key university driver for geoscience education because it affects our numbers. What can we do? Well, we need better public education. We've got to change the mob mentality. We've got to make geoscience hot and great as we know it is, because that's how it's going to have to be to increase the bums on seats.
2 minutes, Greg.
There is another possibility. Thanks, Mark. Another possibility is we could try to get priority funding from the government for this critical geoscience training that we know we need. Maybe they could pay us more and so forth. But I hate to tell you, the bun fight that would make to try to have differential resources in the university would really be a problem. And of course, we're already cross-funding, as has been said. So maybe that's really not a feasible solution. I think public education is the way we're going to have to go. So thank you very much. That's my 2 cents. And thank you for listening.
Thank you very much, Greg. Very much appreciated. Our next presentation and closing off on the setting the scene is by Ned Howard. Ned is a member of the AIG Education Committee and is going to talk about projected graduate supply and demand. So all over to you, Ned.
Thank you very much, Mark. I'm just sharing the screen. All right, thanks very much, everyone, for joining. We've already had some fantastic and very insightful talks so far. So today, I'm just going to talk briefly about what we can and can't see in some of the publicly available data sets, trying to move from having a more anecdotal or qualitative approach to one where, can we be more quantitative about this and see these trends specifically in the data. So I'm going to focus on both workforce and tertiary education related data. And looking at a few basic statistics initially on what self-identified geologists in Australia have said, and then also talk about some of the issues we have in trying to take that more data-driven approach with both the trends and predictions of what we're seeing, both in the supply and demand of geoscientists within Australia. So overall, there are almost 14,000 geoscientists in Australia, according to Jobs and Skills Australia National Occupation Surveys, National Occupation Trend. And so that's people identifying as geologists, geophysicists, and hydrologists, which is a particular occupational category that the ABS has. And so over the past 18 years, we've actually also graduated over 8,000 people with a geoscience major of some kind in Australia over that time period. As people have discussed before, we do have a generally incrementally aging population, with the average age of a geologist in Australia, according to ABS data, currently about 41. And that is similar though to other professional occupations. So we're not unique in having that general trend. So where are the geologists in Australia based? Well, you can see there overwhelmingly Western Australia, with the predominance of the mining industry over there, has about half of the geologists in Australia, with the other states sharing the remaining half, with Queensland again another particularly resource-rich state coming in second there. However, if we look at where the geoscience major graduates based on the AgTep data are coming from, so over that period of 2003 to 2021, we've got about a quarter of the graduates coming out of Western Australia, but the majority, the remaining coming out of mainly what they would call the eastern states and South Australia, and particularly out of New South Wales, Victoria and Queensland, we're seeing just over 50% of the geoscience graduates are coming from there. So to look at employment of geoscientists and how that has changed a bit over time, what are we seeing in terms of in the publicly available data sets and the granularity that they do provide? What can we see there? Well, overall, the number of estimated number of geoscientists in Australia has changed from about 5,500 in 1991 to about 14,000 in 2024. I'd say there's probably about a 10 or 15% error bar on those total numbers based on the fluctuations that you can see in the data. But overall, it looks like we're about 2.5 to 3 times the number of geologists over the last 30 years. So, that is some considerable growth. From the census data we can see from 2006 to 2021. So, what are we seeing in the change of the composition of where geologists are being employed? Well, we've got, about 46%, almost half of the geologists in Australia are employed just in the metal mining industry, about another 13% in the energy sector. That's significantly higher than most of the countries in the world. Christopher Keen's going to be talking a little bit later, but I believe it's a relatively small minority of graduates who enter the mining over there, and also in Europe, and the proportion of geologists working in the mining industry. So we are significantly different from most other countries in that respect. What's changed over that time period? Well, not surprisingly, the metal mining industry is the main industry that's increased their proportion from about 33% to about 46% of geologists being employed there. And so it seems that trend has even been continuing since the end of the last boom. So from the 2016 census, even till now, there's continued to be that increase. And most of that increase in terms of numbers and proportion has come from gold mining and also iron ore. But about 75% of people directly employed in the mining industry in Australia are in gold. So what are we seeing though in terms of absolute decreases, both proportional and absolute decreases? Some pretty concerning trends here in that education and research proportionally have shrunk, and also in terms of absolute numbers of people identifying in the census as being involved in education and research has decreased. Also testing analysis, so that's things like technology distributors and analytical laboratories. And of course, petroleum exploration has really significantly dropped off also. So one thing we wanted to try and do was see if we can look at the data to answer some of the questions that a lot of us have been discussing. Are we producing enough geologists for future demand? Are we producing the right mix of skills for current and future demand? Are we actually in a crisis? Is it a crisis of numbers, or is it a crisis of the makeup of skills? Why do we want to do this? Well, hopefully we can get better informed. We can better inform the actions that we undertake, which things are the highest priority, and what kind of urgency we're dealing with as well. So I've tried to take a data-driven approach, and using a number of different data sets that are publicly available. Most of them from places like the ABS, Jobs and Skills Australia, Department of Education, but also the great data set that Dave Cohen and his priors have put together in the AgTap survey. However, what we generally find in these data sets, once you get into them, is that the errors in the data are larger than the patterns that we're trying to see. So we can map things out and get some general trends, but you start looking at individual components of those, and they have the potential to materially change your interpretation of what's happening. One thing we can say is generally, just to look at a few of these graphs briefly, in terms of the number of geoscientists, that's the Jobs and Skills Australia estimate there in the blue line, and then the number of people identifying as geologists in the census, which is always a lower proportion, has gone from, grown about 2.5 to 3 times over the last 30 years. So that's approximately getting towards a 3% growth rate year on year, which is, significantly, it is higher than the overall population.
2 minutes, Ned.
Yeah, thanks very much. We can also have a look at the different trends in these different data sets, and we can see qualitatively the relationships there that we have in the minerals industry. We can even go to the point of making predictions of that based on the predicted supply with different growth rate estimations. We can put in, consider things like graduates. We can consider retirements, migration, predicted future growth and demand. And if you do that, you can get a picture that makes it look like we are producing about the number of geoscientists we need. However, the problem really is in the nature of the data, in that we can look at this data, but you see there this red line I've just put in there. That's the difference in changing one erroneous data point from one major university. So we can come up with a materially different impression of the data simply based on that. So are we in the crisis? I'll leave that up to other people to say, but we're at least on the precipice, and we're seeing significant forces in both directions for what could happen with geoscientists in the future. The university course rationalisation public perception that's already been talked about is a really significant factor, both in the nature of the skills that geologists coming out have and the total numbers. For instance, Macquarie, Wollongong and Newcastle universities alone in the period of 2003 to 2021 produced 15% of the graduate geologists in Australia. All of those are now closed. So do we need better information to act on? I'd say we don't have time to wait, and I think we have some pretty good indications of what issues we do have now. However, having consolidated, accurate course level completion information, I think would be particularly beneficial. It would allow us to prioritise action where we need to really focus our efforts to preserve areas. And also, you know, if we're going to lobby government and the purse holders, having a data-driven approach and evidence to back up our assertions is going to be helpful. Thanks very much.
Thank you very much, Ned. So that completes the theme number 1. We're going to move on to the second theme, which is talking about graduate skills from a different focus area. Our first focus area is going to be presented by Brendan Howard, who is the General Manager of Technical Capability at Rio Tinto, and he's going to talk about graduate skills from a resource industry perspective. So thank you very much, Brendan.
Thanks, Mark. Can you hear me okay?
Yes, all good.
Okay, great. And it's great to see that the organisers clustered all of the Howards together on the agenda. So, look, great to be here and to share an industry perspective on the supply of graduates and the skills that we need. It's a bit of a frustrating conversation in some ways, and it feels like we keep having the same conversation over and over again. And as I've said in the headline of this slide, I think that's in part because you know, the issue is structural. You know, it is there are no quick fix solutions. No single party can resolve this. It really requires persistent effort from educators, from industry, from government, and it's been building for many years. And I think probably one of the biggest things is that nobody really owns this problem. It's very, very diffuse and very fragmented. So at a headline level, the 3 issues that I think the industry is struggling with is number 1, insufficient supply of graduates to meet demand. The second one is a lack of diversity in the pipeline. The third one, graduates with the skills equipped for the future of mining. If we start with the first one, insufficient supply of graduates, and I think the concerns around supply of mining engineers and metallurgists is probably more acute than it is. That's certainly what I hear from my colleagues more frequently than it is for geoscientists. But you know, we are certainly concerned about what we're hearing in terms of the closure of earth science schools at universities around the country. From the industry's perspective, clearly we want to see a healthy and steady pipeline of geoscience graduates sufficient to meet what's likely to be growing demand for metals to meet the energy transition, the sort of level of demand that everyone's forecasting. The second one, in terms of the lack of diversity in the pipeline, that's not a new issue, but it continues to be an important issue. You know, given that the engineering and science graduates of today will be the leadership cohort defining the culture of the industry going forward. And I think you've probably all heard about the worrying reports about workplace culture in the minerals industry, and a big part of that comes back to the lack of diversity and the need for a workforce that represents the society where we operate in order to sort of drive the sort of cultural change that we want to see in the industry. Geoscience has typically done better than engineering on gender diversity, but I think there's certainly more that we need to do to attract more women and certainly more Indigenous students into the pipeline. I'll come back to those 2 toward the end of the presentation, just to speak about an exciting new initiative that we've got underway called the Minerals Industry Experience Program that I think goes some way to addressing these issues. But first I want to speak to the skills required from the graduates. So we go to the next slide. Basically, at its heart, we still need geologists to be geologists. You know, we need them for finding ore bodies. We need them for evaluating and supporting the safe extraction of mineral deposits. You could argue that it's currently less important to be accurately identifying minerals in the field than it has been in the past, given the growth in the different sort of sensors that are available. But It's just as important as it's always been to understand, the significance of a mineral within a piece of core in the field and what it means in terms of mineral system or proximity to a mineral system. The second one being data analytics. Volumes of data that our geos have access to these days is really quite extraordinary. At companies like Rio Tinto, we employ teams of data scientists and data engineers, and I don't think we need our geos to be data scientists, but I do think they need to be probably more competent with data than they have ever been in the past, and they need to be able to understand what the data scientists are doing and ask the right questions of them. The third one being the skills in the minerals that will drive energy transition, the circular economy. As an example, at Rio, we've, I think, been on a pretty steep learning curve about lithium brines, since we've moved into this space pretty big in the past year or so. Also, I think, as we move into the circular economy going forward, I think we'll find geos getting involved in, recovering minerals from tailings, and otherwise monetizing what was previously considered waste. And I think that's going to be a growing area of importance. In terms of the geophysics and remote sensing, I think that's probably not a new one, but inevitably as deposits are getting deeper, lower grade, that's going to become ever more important. It is concerning the lack of options to study geophysics in Australia today. And then in terms of optimizing our existing resources, once again, that's not a new one. You could say that's always been a requirement for our geoscientists, but it does require a really effective level of collaboration between the geos and the mining engineers and the metallurgists, so they're really building ore body mine plans that really squeeze every last drop of value from the resources, particularly given how hard it is to permit and approve new deposits these days. We need to be making sure that we're squeezing every possible dollar of value out of the deposit that we do have. And then finally, the non-technical skills. Once again, you could argue this has always been important, but the reality today in a global, multinational organization such as Rio Tinto is that, unless you've got skills, capable in working in cross-disciplinary teams, you can communicate effectively to a non-technical audience, and the ability to influence without authority, you're unlikely to get much done. So I know these typically aren't taught in undergraduate programs, but they're really, really critical skills in being effective once you're in the workforce. So look, there's a bit of a summary, a couple of new things there, maybe some things that have always been there, but have just sort of pivoted a little bit. I want to just speak for a moment on what I think is an exciting and really positive development. It's called the Minerals Industry Experience Program. This is, I think, part of the solution to encouraging more supply. This is based on the observation that one of the reasons why a lot of students were not choosing a minerals education pathway was just lack of awareness, or what awareness they did have was based on outdated perceptions of the industry. We just completed a pilot, and what this pilot targeted was students that were in first year or just completing their first year of a science or engineering undergraduate degree, but hadn't yet settled on a major. We took 69 students across Brisbane, Perth, and Adelaide for what was called a 2-week immersion program, and it was facilitated or co-facilitated as an industry initiative between Rio, BHP, Peabody, AusIMM, and the Minerals Council. And what we gave them in those 2 weeks was 1 week effectively in the classroom, exposed to some really inspiring leaders from across the industry. And then on the second week, we took them to site, got to experience what life would be like working on site, and then some other sort of field-based activities afterwards. What we got at the other end of that was a cohort of absolute zealots, really supercharged ambassadors for the industry, ready to make the switch across to a minerals education pathway, and really, fantastically excited about the possibilities of And there's a transformation. If you go on LinkedIn and see what some of these students have been posting, it's really inspirational. So we had nearly 600 applications for the 69 places this time, and there's enormous pent-up demand and opportunity for scaling this program. And so there's lots of opportunities for other companies to get involved and to expand into the big population centres in future in Melbourne and Sydney, and for closer involvement between more universities as we take this forward. So I know it's only one initiative, and I know it's only early days, but I see some real potential from this program.
So 1 minute, Brendan.
That's all I've got. Thanks,
Okay.
Mark.
Excellent. Thank you. All right. Thank you for that, Brendan. Our next speaker is Rona Cartwright, who's going to talk a little bit about graduate skills from a geoscience consulting perspective. She's a hydrogeologist with Cologne, Crippen and Berger. So over to you, Rona. I can see your presentation. You need to unmute.
Thank you. And I've just changed my screen, I beg your pardon.
That's all good.
Okay, thank you everyone. So yes, Rona Cartwright, working for Cologne, Crippen, Berger, and I've been a hydrogeologist with them now for 7 years. So I actually graduated from Scotland. I did my undergrad in geology and petroleum geology, and then I furthered that into hydrogeology after the downturn. So many relevant pieces of information that have been talked about previously about, you know, students taking on further education where you've got the boom and bust in the industry. So before I launch into the graduate skills and demand from a consulting perspective, I'd just like to say thank you to Brent Usher, who's one of our technical specialists in KCB, for his input into the geochemistry side of things, and then Kate Hine, who's director at MITRE Geophysics, for her contribution in the geophysics space. So first of all, you know, consulting, what is it and how does that differ from other work bodies? And we're professionals, we provide a service in an area of specialization. So I guess for myself, I'm a hydrogeologist, but we're here with our clients to help them with their problems and achieve their goals. So, you know, one of the highlights kind of jumping into consulting is the variety of work that we get access to. So, you know, we have a huge variety of sectors. We can go from anything from the coal mining, mineral exploration, we can be working with the government, tailings dams closure. And I think with that, with consulting, there's a bit more space for being fluid and adaptable as to where there's boom and bust. Also are the multidisciplinary interactions that we have. So not just within our own team. So the geoscience team can be made up of your geochemists, geophysicists, hydrogeologists, your GIS spatial team, modelers, but also then the wider interaction. So we were talking about it earlier, the non-technical groups, you'll have stakeholders, your clients, you'll be interacting with drillers. All of this is really important to be able to kind of bring people on the same bus, but bring them along with the story and kind of solving the problems together. And another massive highlight has been the opportunity to travel. So, you know, you can't sort out a borehole from a desk. You have to get out into the field, you have to kick the dirt, like the rock, so to speak. And, you know, from my own personal experience, you can be in far-flung Papua New Guinea, into rural parts of WA and rural parts of New South Wales, and even the tropical side of West Coast Tasmania. So for students then coming into consulting, the expectation of spending a lot of your early years in the field. And, you know, we've seen that kind of downward trend of, maybe it's because of COVID, but students being less willing to be out in the field and being in remote locations. So that is certainly an expectation. Being good with time management. Consulting can be quite fast paced, which some people love, and some people it can be more tricky. But also then having the opportunity to learn on the job, which can certainly, you gain experience and your new skills in which you kind of benefit from and improve your early career. And then all this being working in a team, and how much you actually have to bring as a graduate and, you know, bring to the table. So looking at the skills required specifically for a hydrogeologist, a geochemist, and a geophysicist, although these are some specifics on paper, there's actually a lot of overlap, and typically we look for a lot more than what's just achieved on paper. So going back to basics, geology, whether that's your petrology and mineralogy, sedimentology, field geology is certainly a big one that, you know, you might do just a very basic course maybe in your second year, but then building on those skills. And certainly when I did it back in Scotland, we did a 7-week mapping project as part of our honours. So all this, you get very valuable skills, and where it's not straightforward out in the field, it's certainly contrast to lovely, straightforward in the classroom kind of examples. Furthermore, you might do mining geology, modelling. Like, this list is endless, but you should be quite selective with your electives in terms of getting like a really good solid foundation for geology. Then if you're wanting to pursue the hydrogeology route, doing hydrogeology specific courses and then furthering that with an honours project. So you're demonstrating that you can work with real life data. It's typically not straightforward. There'll be gaps, and kind of dealing with real life problems. So all on top of this, your exposure to field work. So I think the mining industry experience, I think, is a fantastic initiative. It's a really great example where, you know, if you're a student and you're showing willingness to go out and get exposure to the real world, I think is fantastic. Also, you've got opportunities like going to guest lectures, integrating with mentors. All these pictures here from a variety of my own field experiences, being up in Papua New Guinea, New South Wales on a sampling project, and a very wet and soggy Tasmania right there. So what we've got is the willingness to work remotely, and then all through that, a communication. So you're working with different teams. A lot of these guys are here. We're locals in Papua New Guinea, and first language being Pidgin. So you imagine trying to get them on board on the same page, going through more complicated testings and things like that. So looking then from a geochemist perspective. So good foundation in geology, furthering that then with chemistry subjects, and then geochemistry subjects. So that might be geochemistry and geofluids as an example, or the petrophysics of mineralogy and rocks. More so, you've got mathematics, so being able to balance equations, building on from the technical side of things, having exposure to fieldwork. So how, this is an example of rock analysis from tailings dams, and how you would then use these, and, you know, these are piles of rocks and these have obviously come out from a drill hole. Are you able to look at these and analyze these in their different formats? Your problem solving skills is very important. And then again, working in the multidisciplinary team. So being able to tell the story and how to solve the problem with everyone involved. Skills then required as a geophysicist. Geology, of course. So the kind of mineralogy side of things, as well as your rock types, your main ore deposit types, formations. Structural geology is certainly an important one. You might, in the real world, look at fluid flow. So understanding how the different makeup of rocks and what you would then look at from a geophysicist point of view. So that's strong theoretical knowledge. So whether it's in magnetic, so your induced versus remnant, your primary fields, your processing and filtering and image presentation, your gravity, EM and IP. So what is resistivity and chargeability? How is data recorded and displayed. So this is a great example. Again, these are my own photos, but working with a geophysicist in Papua New Guinea, you're gathering the data in the back of a ute. These are never done in aircon conditions, but also then so data processing, modeling, but drawing your attention here, if the temperature of the water that you're actually putting your instruments in is almost 145 degrees, how are you going to work with this? And does that change what data you're collecting and instruments that you're using?
1 minute, Rona.
Thank you. So your exposure to fieldwork and communication through all of these has been really important. So for what now for students? All three of these have shown that there's an overlap with having that solid foundation of basics and then being very selective with what electives you take and what path you go down. Having real life experience is incredibly important, and then your attitude is really an asset through any of these. So being willing and having a can-do attitude can take you a long way. So thank you very much.
Fantastic. Thank you very much, Rona. Our next presentation is by Steve Hill. He is the Chief Scientist of Geoscience Australia. Welcome, Steve. And his talk is around about the graduate skills from a government perspective. All yours, Steve.
No worries. Has that come through?
Not yet.
Not yet? Okay. Let me just make sure I've pushed the right buttons. Share. Getting there. How's that? And then I'll just put it on presentation.
Yep, I can see it. It's not on presentation mode yet, but I can
Should be
see
now.
it is now. Thank you.
Okay, so firstly, I'd just like to thank AIG for giving someone the opportunity to represent the stream of government geoscience careers and to talk a little bit about what are some of the characteristics of that and how that might link back to geoscience education. It's probably an area that I must confess is not always very well known about. I know that when I was a geoscience student, I had some very vague idea about geoscientists going and working in government, and it was mostly through a government subject matter expert touch point. And I think that sort of perspective actually continues for many of our careers, where what we know about government geoscientists is usually very dependent upon our touch points and the sort of things that we're interested in finding out from government. What I've found since becoming a geoscientist, initially in state government and now in the Commonwealth government, is that it's incredibly diverse. And so I'm just going to talk a little bit about that and what that means for our discussion here. So as I said, the touch points, but what does that mean? It means that by it not being particularly well known is that there is actually limited initial choice for people moving into government geoscience, and also the mobility both into and out of and across different sectors is quite restricted. One of the outcomes of that is that we do have a challenge about having diversity and knowledge, particularly in our knowledge creation, both internal to government, but also the geoscience community that we tap into, finding that that diversity is also a challenge in that area. So I said, yes, there's social diversity and some of the things we traditionally talk about, but I'm also talking about the diversity of really science perspective and knowledge creation. And that then feeds into impacts on innovation and the scope and nature of the science that we're looking at. Okay, so this is a bit that I think shocks a lot of people. I think when we talk about government, we often think about people that are kind of administrators, bureaucrats, people that might be restricted to a certain, say, a geological survey or a certain part of government. Reality is that it is incredibly diverse across different levels of government, national, state, territory, also local government employs geoscientists. And just as a bit of a framework, there's more than, or estimated to be more than 20,000 science jobs in the Australian public service. As an example, about 700 of those are employed in Geoscience Australia. What's interesting, though, is that less than 1/4 of them, first and foremost, identify as a geologist, and about half as a geoscientist. And I'll show you some data on that in a minute. The other thing to think about is that a lot of geoscientists work for PFRAs. There's my government acronym for you, but that stands for publicly funded research agencies. So CSIRO, Geoscience Australia, Bureau of Meteorology, Bureau of Statistics, and the Australian Space Agency, and many others, but they're just some examples. And then there's also people that work in the government public service more directly or more traditionally in the departments. And there's just some of the example of the Commonwealth ones there. And there's certainly plenty of geoscientists working in those areas. And at the end there, I've got listed a whole range of sub-disciplines, starting with geologists, geophysicists. But I really want to point out that the definition of geoscience that we use at Geoscience Australia and that I'm using here is geo meaning earth and science meaning, well, science. So the science of the earth. And we're looking then at quite complicated and integrated earth systems and how they come together. And as a result, our expertise is extremely broad. I know this is a bit small, but the point I want to make is that we have done mapping of our capability and capacity of our scientists at Geoscience Australia. And there's a segment down the bottom there listed under geology, and you can see it's only a fairly small segment. And there's incredible diversity across things like business management, digital science and information science support, and also particularly things like geospatial science and earth observation. Really important to show that diversity. These categories that I've shown here are the same Australia, New Zealand occupational categories that we used in many of the other studies shown earlier. So what does this mean? Well, please be aware of the broad definition of geoscience and the diverse roles where science of the earth is valued and in demand. And geoscience is not just defined by what your lecturer has done in their life. And we do see that come through a fair bit. And it's larger than any individual in its expertise. So next, I want to talk about why. So why do we need geoscientists in government? Well, it's because we need to make informed, evidence-based science decisions. And here we see a great example of our Prime Minister using Geoscience Australia flood data during Cyclone Jasper and showing flooding in the Cairns district. This warmed the cockles of our hearts to see our data being used and having a direct impact on the well-being and lifestyles and life of Australians. And this is a big reason for why we do it. So what does that mean? Well, that means that government geoscientists have a key role in our society and for how we best live with the planet. We also need to work with a diversity of stakeholders. I think that's one of the big differences. People often judge government geoscientists by the one stakeholder channel that they're part of, but I must say it is incredibly diverse, and that government geoscience has an impact on all of us in ways that are sometimes hidden. And so this next part where I'm actually looking at what really shows some of that diversity of stakeholders, that interface that we walk between government, and that's internally in government, research, industry, and community. And that importance around the work that we do being usually mission-orientated, long-term research programs of national priority and benefit. And so trying to solve practical problems that directly affect our society. Got a few examples there. I love the one on the bottom left that really shows that we are using geoscience coming from government many, many times a day with our positioning work. So when we use positioning and navigation on our mobile phones. So what does that mean? Well, that means that our work in government is applied. We have a strong organisational alignment, and our key outputs tend to be things like reports, scholarly articles, databases, public guidelines, etc.
A minute, Steve.
No worries. So actually, this is coming right to the end. How do we then sustain government geoscientists in the future? And this is where it comes back to this geoscience education. We have a really high demand. We actually struggle to get people or enough quality applicants for our positions as a general rule. And that's really reliant on the through flow of university geoscience and STEM graduates. And this has been a challenge, and already we are recruiting people with high levels of subject matter expertise from overseas where we don't get local suitable candidates. And some of the areas are around things like community safety, so earthquake, tsunami, but even into the positioning and space science and how that relates to geoscience. And many parts of government have a strong education and research program, and we certainly have that at Geoscience Australia. So what does that mean? Well, although, for example, at Geoscience Australia, we don't have a direct education mandate, we're highly supportive of university geoscience programs, especially across that broad definition of geoscience. We prioritise our own internal work in the Education Centre and our community and stakeholder outreach programs. And there's probably a lot in this last point here. We're keen to see university geoscience departments provide strong business cases. And I think that's been touched on a bit already, that a lot of the problems we're facing with geoscience education continuity is not about quality or anything like that. It's actually about the business cases and how that's being put forward. And then also we even find that finding the specific capability and capacity of different university departments is a challenge to have defined. And that has an impact on how we build greater and sustainable partnerships with universities. There we go. I think I've landed on time. Thank you, everybody.
Excellent. Fantastic. Thank you very much, Steve. We're going to have a break. We will be starting again at 12:05 p.m. sharp Australian Eastern Standard Time. So if you want to have a walk around, stretch your legs and do whatever you need to do, then please feel free to do that. We will be starting again in 15 minutes. So thank you very much and see you shortly. Thank you to everybody who has rejoined. We still have a very large number of attendees wherever you are around the world. So we're going to move on to the third theme for today, which is talking through survey results, which is what do students want, with a focus on three different presentations. The first is being done by Professor Peter Betts, who's at Monash University and is a past president of the Geological Society of Australia. It's what employers and academics think that students want. Over to you, Peter.
Yeah, thanks, Mark. I'm actually, whilst that's the title I was given, what this survey that I was engaged with is really about is what employers and academics think, what do they think why students don't show up to the degree or to their career. So it's really a presentation about a survey that was done widely and to understand it, and it's published, so you can access it. It's in a book chapter related to geoethics for the future, and the title of that chapter is A Global Geoscientific Skills Gap Threatening a Sustainable Future. And so the major author on this book chapter is Julie Hollis. She's located in Belgium, in Brussels. Myself, Caroline Tiddy, and Glenn Burridge were the other contributors. Okay, let's see if I can go forward. There we go. So I'm going to tell you what this survey doesn't tell us about. It does not address anything about how young people perceive earth scientists. Rather, it tells us about what we perceive as the challenges that we face as a geoscience community. And so the survey was set up as two separate surveys. One survey that was industry facing and spoke to employers of geoscientists, and the other one was education facing and really engaged with the tertiary education community. The two pie charts that you can see there, the one on your left is really addressing the distribution of the respondents from industry, and the one on the left is the academic community, as my dog goes off his nut as someone knocks on the door. This is kind of the sort of the generalities are related to the respondents to the survey. On the left, you can see where the major respondents were from. So mainly exploration surveys, government and mining companies, and universities, consultants, and was pretty much the cutoff, and then every other area had significantly less respondents. Broad diversity of organisations, many with employers less than 100 and several with more than 50,000 employees. And the bottom data shows you the proportion of the respondents that were female. So here's some results. We really asked about employers, their perceptions about the employability and so the employability, but also what their perceptions are, why, and the challenges that they face in employing in graduates. And you can see there's on the left-hand side a whole series of responses related to those questions. Interestingly, the major responses, and so I should remind you that all the responses could choose multiple sections or multiple responses, so that's why the numbers are more than 100% as responses. But access to quality candidates was the major responses for why it's more in a more difficult part of employing graduates. And I think that's an important point, and it came out clearly, and it really talks to I think the quality of education globally, and we might have heard some reasons for that in the last few talks around blending of courses, blending of curriculum inside individual units, etc. And I think employers are starting to pick that up. I think it was Martin's talk said it's been noticed in the last 5 years, but it's actually been going on for a lot longer. And most of us in the room can remember when we were educated, and then when I reflect on the offerings now, it's a different beast. The students certainly come out with a different set of skill sets. Budget was another one, and then I think that the lack of or difficulties related to that become more about the candidates themselves, so their interest in geosciences, so students not wanting to be a geoscientist, the poor perceptions of a geoscientist as a career. I think we hear that in multiple places now, and the employability conditions. One of the things that came out, and I think this is really surprising, and I think it talks to our perceptions of ourselves rather than the reality was the perception around diversity in geoscience and the perception about inclusivity in geosciences came up as relatively low as a reason. And we know from other data sets that this is probably not the case, and it probably talks to our perceptions as ourselves. As an overall summary, 59% of employers that were surveyed said it's more difficult to find a graduate than it used to be. And only 15% said that there was more. And then the last bit of information that really came from this was that about 60% of respondents felt like there was a real or a perceived geoethics challenge in the geosciences, and that came out in the data as well. So this is really the summary of that element of the survey. So budget is just another driving factor. I didn't mention that before. A high proportion of our respondents noted that there's an increase in difficulty in attracting qualified geoscientific staff. Access to qualified candidates or that's the same point. Basically says is the perceived factor in increased difficulty in attracting staff. And then of the majority of the respondents who felt there was a real or perceived geoethical challenge, the most common response for that was the poor perception of geosciences, and they basically highlighted that this is particular amongst young people, and I think this is consistent with the messaging that we've seen and heard, not only in today's workshop but also in other forums and surveys that we have got. And then within a subset of that, of the poor perception, there is definitely a negative perception related to environmental mining and how it links to environmental and climate change. And I think there's studies out there that demonstrate that as well in Australia, particularly the ISIMM databases. When we asked the questions to the tertiary educators, we really wanted to find out why they thought there was a decline in student numbers, and their responses were not that surprising. The top one was the perception of geoscience in a career, and then a perception of the environmental relevance of geoscience, and then interest in geoscience. Again, the academic community didn't think that there was a problem with inclusivity or diversity, which was surprising. I know in my school, we talk about that a lot, and we're actually called out on it quite a bit. For the undergraduates, 79% of the people that responded said that there was an overall decrease in undergraduate enrolments, and only 16% reported an increase in first-year enrolments over a period of time.
2 minutes, Pete.
Thanks. Yeah, there's the laundry list. I should get it done. So there's the laundry list of the various reasons. I'm not going to go into the details except for the highlight the main ones. When we look at master's programs, similar story. And the reason for that is the perception in geoscience careers, but there is a shift in the reasons. So there's a decrease, but there's a shift in the reasons. And one of them is more around the career path, so around the employability conditions and the instability of the job market. And I'll touch upon the reasons for that in a minute, and the numbers are there, and those numbers in the bottom, which I'm pointing to, the last 4 points, are really linked to the broader, not major and moderate events. Okay. So last one is PhD program. Again, I was surprised by this overall decrease in enrolments into PhD programs. Perceptions in geosciences careers is the major one. For the respondents that said there was an increase in PhD enrolments, it really was focused around the interest in geosciences, but also positive perceptions of the relevance of geosciences from an environmental perspective. And I think that talks to, advanced students who've gone through education process in undergraduate, maybe masters. They're more aware of the social reasons why we have careers in geosciences, for example, in mining, etc. So last slide. The perceived impacts on declining undergraduate numbers were mainly related to negative perceptions of geosciences and the lack of awareness of the social relevance. And that's the similar sorts of messaging that came out in early talks, for example, in Brendan's. For postgraduate courses, all kinds of declining student numbers are less significant compared to undergraduate declines. The perceived reasons for declines are mainly linked to career issues and the job market, rather than a broader perception of the discipline. And the other thing that came out of this was the difference between perceptions in driving trends in undergraduate and postgraduate students is a sort of a logic that postgraduate students will already understand the social and environmental relevance of geosciences. So they're more in tune with the types of career prospects, and maybe have made their peace with those prospects. So I think I'm going to leave it there, and thanks for the opportunity to speak today.
Excellent. Thank you very much for that, Peter. Very much appreciated. Our next presentation is by Jenna McGovern. Jenna is a member of the AIG Next Gen Geos group, and she's going to be presenting a range of different surveys. So over to you, Jenna.
Hi. Cool. So is that working for sharing screen? I'll just have to check that my presenter
Yep.
set up the correct screen. Yep.
It's perfect.
Okay. Awesome. Hi. Yeah. So I am the 2025 chair of the AIG's Next Gen Geos group. And basically what I'm presenting today is a combination of previous surveys that were run by other members of NGG, both from 2016 and then more recently in 2024, I believe. And then also just a range of other publicly available surveys from Australia and beyond. So these are the ones I will be covering today. I'm going to try and blitz through them, which means I am going at quite a high level. If people want more information, I can try and make these available to anyone who's interested. If they just want to add something to their feedback form about that. So the themes covered in these surveys include what career choice drivers are present in current graduates and students, the demographic of the groups being surveyed, what employers used to look for in graduates anyway, around circa 2016, which I guess tells you a little bit about what skills might have been taught since then, and also I think really highlights a problem with seeing a lot of the things that employers have actively said they want versus what courses seem to be getting low or high enrollment numbers, perceptions of mining and geosciences in the upcoming workforce, and some student suggestions from previous surveys on future efforts to attract and engage with geoscience students. So I haven't covered everything from these. I've just kind of cherry picked a few questions from each to show a bit of a story. From the 2016 one, keeping in mind that this was almost 10 years ago that this survey was done by Josh Lee, one of the previous chairs of what was then the National Graduate Group and is now Next Gen Geos. Employers back then were looking for people who were first and foremost inquisitive and showed initiative. So over things like being able to handle criticism or having people skills or critical thinking, first and foremost came those very much kind of inherent soft skills of just being able to question things and show a bit of initiative about maybe where to seek out or how to seek out those answers. One thing that became pretty evident from this survey was that when more senior geos were giving advice to younger geos, there's, as mentioned in previous talks, it's very obvious that the boom bust cycles are quite a detracting feature when looking at how to attract people to the geosciences. And the advice basically was that you need to be able to be resilient, don't become a specialist too early, you know, try and use the busts to upskill. It was very positive. However, when it then went into, you know, the concerns about the current downturn, all of the niceties sort of went away, and it basically came out that this is just reality, and that it won't last forever. Oh, well, you'll just have to deal with it. So I did want to highlight that because I think that potentially we need to think about how we can change that narrative to maybe support people through those busts better, or create a future where, you know, geoscientists aren't just taxi drivers every time there's a bust. The most useful skills learned at university from people who were in industry back in 2016 included field skills, a strong understanding of geoscience, research and critical thinking skills, mineralogy, ore deposit science, and then writing and project management. They were the top ones. So what I thought was interesting about this is obviously field techniques being the number one thing that people found useful when they went to industry is very quickly becoming harder to get experience with in the university systems. And not much of a surprise given that critical thinking skills and showing initiative and a bit of inquisition being all very valued, honours at least was desired from those already working in industry. Flash forward to last year when the NGG ran a similar survey across New South Wales, Victoria, and Tasmanian universities. And what came out of this was basically an understanding that a lot of the students going into the geosciences now are very concerned about the perception of mining, but they're also very driven by the potential to make the industry better and contribute to a greener and a better future. So while there is a lot of things that act against the mining industry, a lot of these also inspire people to want to go into the industry to change it. So basically, lack of career exposure and stigma against mining, along with geology being deemed boring or a lesser science, are the three main reasons why people perceive others not going into geosciences. The recommendations from this survey was to increase education opportunities, ensure students are well educated about what the jobs in each sector entail early on in university, and facilitate additional short courses to increase exposure to areas where we might need help. There was a survey put out by Year 13 and AusNISA. This was quite a recent one, and it covered off on quite a lot of Australian Gen Z people who had quite a high level of understanding that mining is very important or extremely important to the economy, with the amount of people selecting that as between 85% over in WA, which is a very resource-driven state, to 57% in Victoria. And 73% think that mining does more harm than good to the world. So there's this really clear pattern emerging of the newer generation thinking that mining is very important, but it also does a lot of harm. Overseas in the UK, and this is particularly interesting through the lens of what the previous graphs showed about enrolment numbers over in Europe and the UK, because the recent review that came out last year on, I guess, perceptions of geology in the UK is that it's pretty boring. A lot of people didn't really know what it was in the first place. People understand earth science, but not geology. It has very low diversity rates and is seen with sort of quite old stereotypes and being quite inaccessible to a lot of people, and is also known to have a lot of destructive practices and not necessarily encourage sustainability in professions. Tried to blitz through this, so I'm definitely within my time, but basically out of all of the surveys that have previously been done here, we can see that current students do understand the importance of mining, but don't necessarily understand the career paths available to them. So those who go into it are driven by the fact that they want to be a source of change and see the industry become better, so that then the need that we have for mining isn't detracting from our ability to have sustainable practice in mining. A lot of people won't make that connection though, and I think that's something that could help to encourage more people into geosciences, is actively reinforcing that connection between the cause and effect at a younger age group. Because otherwise negative perceptions of mining are going to turn a lot of people away from the geosciences. Students are more deeply motivated by wanting to create meaningful careers than they are by high salaries. And in a lot of cases, in the stuff I didn't get to go into, some people aren't aware that you can make a lot of money in the geosciences. They don't think about it as having a high earning potential in the first place. Yeah, so if there's anything more that people want to know from the surveys that I've covered off on, feel free to pop something on your feedback form and we'll make that available to you.
Thank you, Jenna. Fantastic. Our third presentation in this theme, which is presenting survey results, is a joint presentation by Kayleen Kamuti and David Cohen. Kayleen is the chair of the AIG Education Committee, and David we've already introduced previously. David is in fact online, but my understanding is that Kayleen's presenting. So over to you, Kayleen.
Thank you, Mark. I'm assuming you can see my screen. And I do apologise, but I am going to give 2 talks in a row with no break in between, because that's just the way the program ended up. So the first presentation is a summary of the results. It's a very high-level summary, time constrained, of a survey that was run nationally of students and geoscience graduates by the Australian Geoscience Council last year. Sorry, I just have to. I do apologise. I've just lost the control of my. Yes. Can you see my full screen? Hello?
Yes, no? I can see you're not in presentation mode.
I'm not. Okay, because it keeps. I cannot. Sorry. I'm having a bit of problems. Okay, that's it. Thank you. So the key objectives of this survey were to get some idea of the awareness and familiarity that students have with geoscience and earth science. It sort of all got bundled together. To find out more about the key motivations and barriers to student uptake of courses. Find out a little bit about how appealing and relevant students consider the current tertiary offers and how that information is communicated. And identify key opportunities for initiatives and messaging. So over the course of 2024, we engaged the market research company 55 to undertake a qualitative and quantitative study. This started with a review of previous research and surveys, and And the first phase was qualitative research comprising an online community and in-depth interviews of Year 12 students, first and second year science undergraduates, both those who had and had not chosen a geoscience major, recent geoscience graduates, and a career advisor. This qualitative data was then used in the structure of the quantitative survey that followed, which involved over 200 year 11 and 12 students and about 160 first and second year students. So this is just going to be some snippets from the survey, hopefully that highlight some of the major findings. So one of the questions that all the students were asked in the quantitative survey was, which of these do you consider important when choosing what you want to study in the future? And both school and university students gave very similar responses. Interest in the subject matter, which is really good, was the top one for school students and close to top for the university students. And job security and job opportunities were also highly important to the students, which echoes what Jenna has said on the basis of the survey she's been considering. Earning potential was also important, and students wanted to do something that they're good at. In the qualitative survey, when they were interviewing students, it really highlighted the major barrier. Actually, and this has come through in Pete's talk and in Jenna's talk. Many students know very little about geoscience or earth science. They don't even know it's a subject. It's not offered in schools, and they don't know what it consists of and what it leads to. So some of the comments that came back was that it's boring, it's just rocks, or it's similar to geography. It's less credible or respected than core science subjects and easier to get into. The negative stigma of mining appeared again. It's detrimental to the environment and poses ethical dilemmas. The workplace conditions are challenging, isolating, remote locations, involving manual work. That it looks to the past, not the future. It's not part of future solutions and doesn't appeal to altruistic goals. That it's niche with an inflexible career pathway, few transferable skills and limited career opportunities. That it's lower priority in science faculties and universities and so has fewer resources. And again, dependent on the boom bust cycle in the resources industry, so it's not a stable career option. So they were this is some of the barriers. The researchers talked further to the students and provided them with information about geoscience and earth science courses and career opportunities to find out what out of those appealed. And some of the appealing aspects to the students who is the opportunity to work in a variety of locations, in either urban locations in an office or in a lab or in the field. The ability and opportunity to travel and live in different places. That it was highlighted that it is possible to contribute to a more sustainable future and some of the challenges ahead. To some students, being outdoors and close to nature was a positive feature. And to some, it was the opportunity to engage in challenging projects and problem solving using advanced technologies and to work with interdisciplinary teams. So when do students make decisions? Because in terms of the initiatives, any initiatives geared towards creating a wider exposure and higher profile for geoscience, when is it most effective to talk to students? The survey, and I think discussions with careers advisors and teachers has also highlighted that it's year 10 is the year when students do make their selections for years 11 and 12. In year 8 and 9, they're thinking about electives, they're trying to determine their interests, their strengths and weaknesses, and tossing around a few ideas. In year 10, the career advisors become very much involved. They expose students to a range of careers, subject choices, alternative pathways. They might expose the students and give them opportunities for work experience. In year 12, students are very much focused on their HSC performance and are much more concerned, for the most part, about getting their best results rather than what happens after school. But in year 11, whilst the pressure is beginning and they've already made some selections, they are still considering things. Career advisors get involved can provide events and experiences for them. And so that it's a good time to still keep in touch with students. And what influences the decisions? So 345 university and school students were asked, what influenced your decision or preferences most when you chose what you wanted to study? The red arrows indicate all of the factors that relate to universities, and it indicates that universities potentially can play a very big role in students making the decision. Course descriptions came out as the most influential factor. The reputation of the university websites, the location of the university, some over which we have no control, but university websites are a major source of information for students. The reputation of the department and their interactions with current university students, university lecturers and admission schools are also can have an influence on their decisions. Schools, it's dominantly teachers and the career counsellors that are influential, and of course their parents and family and friends can affect their decisions. So to me, two things were highlighted that came out of this, was the importance of university websites and course descriptions, but also the role of careers advisors. They play an important role within the schools and the key gateway to information on future studies and careers for both the students and their parents. They are a conduit for students to information sessions, newsletters, campus and industry experiences, and they help students identify their strengths in the context of potential careers.
2 minutes, Kayleen.
Okay, thanks. To do this effectively, careers advisors need knowledge of the courses and an understanding of the skills required for a course in a career. They are helped if they have access to engaging presentations or displays that students enjoy, and if they can offer to students course, campus or career experiences that encourage interaction. So what can we as a geoscience community do? I mean, none of this is particularly new, but I think the value of the survey was it did highlight some areas where we might be able to expand, fill in some gaps in terms of support. So what can we do? We can support teachers and careers advisors to encourage them to include geoscience or earth science on subject lists and explore its potential careers. We can do that by providing a relevant professional development and teaching resources to teachers and providing careers material that demonstrates relevance in the breadth of study areas and the opportunities, that emphasises how geoscience can address future challenges and that highlight the wide range of career opportunities that are out there. The other thing we can do is we can make university websites and course descriptions informative and engaging and easy to navigate. And perhaps we can help provide opportunities for school students to meet working professionals and university students. So that was just some of the highlights that came out of the survey. There's a lot of information in the survey that we're still pulling apart. I'd like to say thanks to the Australian Geoscience Council for funding the survey and the staff at 55.5, because they were a pleasure to work with. They're very committed and professional. And to all those students and graduates out there who contributed their time and took part in the survey. So thank you for that. And I will move straight into my next talk.
All right, I'll just introduce that because that's the closeout of the theme 3, which is talking through survey results. And this is now moving into current initiatives and are they addressing the issues? Then the first presentation is to continue by Kayleen, which is an overview of current school initiatives. Thank you.
Thank you, Mark. So I'll start with this graph, which isn't very encouraging. In 2022, the data for Year 12 STEM subject enrolments this is Australia-wide, indicated that around 50% of students enrolled in STEM subjects in Year 12 are enrolled in a maths subject, in maths subjects. Amongst the sciences, biology, chemistry and physics have decreasing numbers of participants. Engineering, surprisingly few, and earth and environmental science, about 1% of students enroll in that subject. So I guess that's in a way, it highlights the the issues that were discovered in some of the issues in the survey: lack of exposure, lack of courses, lack of availability, and it's highlights the challenges. So in this talk, I'm going to focus on briefly on four school programs that largely can focus on geoscience education in schools. There are other programs out there, and I'm sure there are ones that I don't know anything about, but these are the ones we're most familiar with through the AIG Education Committee, and I just like to take the opportunity to highlight the work that is already being done there, and ask what more can we do. So the Geoscience Pathways project is located in South Australia, and its prime purpose is to support teaching of earth and environmental science in South Australian schools. It does that through providing professional development to teachers, along with teaching resources, assessment resources, and ongoing mentoring. It's a collaborative partnership between schools, industry, and professional associations, and it has the aim of giving more students the opportunity to study earth and environmental science, with the possibility for some it could lead to a career. All the resources required to teach a subject are provided to the school free of charge, and teachers are offered free professional development and ongoing mentoring throughout the school year. Since 2022, that should be, the number of schools teaching earth and environmental science has increased in South Australia from 1 in 16 to 1 in 10. So that's a success, I would think. Most of you, particularly those in WA, would be well aware and familiar with the CORE program, which has been going in some form or another effectively for a couple of decades. This program focuses on connecting students to industry pathways. It has immersive geoscience field trips, project-based learning on key topics, industry knowledge and exposure, and it offers professional mentorship for the educators. In the eastern states, we have the Teacher Earth Science Education Program, TESE, and this program has been going since 2008, and this is a distribution of the workshops, school incursions, field trips that have been delivered around the country since that time. It's a program, and this is where it is somewhat different to the others in that its focus has always been about educating the teachers, and with the aim of developing enthusiastic and well-informed STEM teachers who are confident to teach earth and environmental science. The workshops for the teachers and for lab technicians are delivered in person and online. They're presented by experienced industry professionals and science teachers. Classroom sessions are also done at request of schools, and talks and careers and field and mine visits. And TCEP also has produced rock and mineral kits for schools and a plate tectonics poster that is available. So, and probably the longest, the earliest of the main earth science education programs that I know of is the Oz Earth Ed program, which began in 2003 in Western Australia and has since developed programs in the Northern Territory and New South Wales and South Australia. It reaches students via incursions and educators through incursions and also professional development. It has student field trips and provides grants for field trips. It also has an abundance of relevant curriculum, relevant publications and resources online. So what is apart from commitment, dedication, grit, and what is the other common feature amongst all these programs? And that is they rely on some form of sponsorship, partnership, whatever, to survive. Their funding is by geoscience organisations, companies or government industry bodies, sometimes through the sale of publications and rock and mineral kits. There's still some reliance on volunteers in some cases, but I gather it's a never-ending task to continually source funds to ensure their programs survive and hopefully grow. And their reach. In 2023, Oz Earth Ed reached over 17,000 students through classroom incursions and field trips, and provided professional development to nearly 900 educators. TSET provided PD for over 2,000 educators, and classroom incursions about 2,800 students. Core learning, over 1,000 students in the program, and professional development for 25 educators. Geoscience pathways, around 400 students benefited from the teaching resources, and 20 educators were involved in mentoring and professional development. So all of these programs are out there. They're reaching out to students, they're reaching out to educators, but it's a big job. And these are just some figures that I was just curious as to how many students there actually are in years 10, 11, and 12. And in 2023, was over 840,000 students enrolled in senior high school. There are over 150,000 secondary school teachers. Most of those obviously are not science teachers, but it means there's a lot of teachers and there's a lot of students out there. And it would be great if we could extend the reach with some of these programs. And if we think about how we could do that. So I'd like, and what I also wanted to mention was too, that in those programs, as far as I know, one of the gaps was that I don't think any of those programs directly reach out to careers advisors. So that may be a gap that we should be considering filling, and also considering how we can raise more funds to give these programs a more secure future where they can plan ahead and extend their activities. So thank you.
Excellent. Thank you very much, Kaylee. Our next presentation is by Dr. Kate Salway, and she is the Managing Director of Vox Geophysics and is going to talk through a summary of tertiary and ECG initiatives. So over to you, Kate. You're on mute still.
Can I just check that you can see my screen there?
Absolutely.
Great, thank you. Thanks so much for the invitation to speak today. My background personally is mostly in academia. I was one of those academics who was made redundant from Macquarie a few years ago. So I've got lots of kind of close-up experience of the challenges of working within universities. Since then, I set up Vox as a consultancy, but also run CAGE, which is a geophysics kind of training course, late stage uni. So with that background, I'm talking today on tertiary and early career initiatives for training in geoscience. And just to summarise some things that we've already heard today, and thinking especially about challenges, especially of geophysics undergraduate teaching, which is my background. If you were wanting a graduate geophysicist, you would want there to be a broad range of content that they would know. You would want them to know about a broad range of different geophysical techniques. You'd want them to know about inversions. You'd want them to have field skills, really a broad range of knowledge. And so from the university's point of view, that means hiring probably multiple academic staff. That's a big expense. Running field trips, that's another big expense. They'd need to buy a lot of equipment. That's another expense. They need to buy software. All of these things are possible, but as we've heard, the real challenge is that we'll have small undergraduate cohorts. So, I mean, especially in geophysics, you might expect not many more than 5 or 10 students to be in a geophysics major, the third year course. And so if you're a university bean counter, that equation just doesn't weigh up. You'd, as a university, spend so much money on so few undergraduate students. And that's really why we've lost so much geophysics training in Australia over the last 10 years or so. And obviously the ultimate solution to that is to increase the numbers of those undergraduate cohorts, as we've just been hearing from Kayleen. And yeah, hopefully that happens. But the current reality, and the reality, even if we have this fantastic increase in undergraduate numbers, the reality for the next few years is that we'll have graduates coming out of our universities that won't have all of the skills and training that we might want them to have. And we'll also have, and as we can already see, a lot of graduates coming from overseas, which is great. They may have had fantastic training overseas, but there'll probably be some Australia-specific training that they haven't had. So our challenge now, in this immediate time, is how does we as a geoscience community fill this gap? And so I'm going to be talking about 3 initiatives that are happening in that tertiary space. Firstly, CAGE, that I'll mostly speak about because I know it because I run it, and also Nexus, and then postgraduate courses. And I'll talk about these as examples but also kind of highlighting some of the broader opportunities and challenges. So CAGE is the Camp for Applied Geophysics Excellence. We've been running just since 2022. And the goal with CAGE was really to address that loss in field geophysics teaching at universities. We figured we can't do everything, but that was a gap that we could potentially fill. So our goal was for maybe geophysicists who've had really great kind of theoretical and computational training at university, but have maybe never stepped outside and dug a hole, to give them that experience of where the data comes from. But also for geologists who maybe haven't had the opportunity to have much geophysical training in their undergraduate degree, but are then going to come out and sit at a desk and have a geophysical model land on their desk, to give them enough knowledge to know what kind of questions to ask of that model, what kind of questions to ask of the contractor who produced it, to be able to make intelligent decisions based on that geophysics. Very hands-on, we kind of call it sort of farm-to-table geophysics, where the attendees go out, collect data, model that data, and then interpret that data. And the ultimate goal is to have graduates coming out with better geophysical skills and making better geophysical decisions. CAGE is a week-long camp. We spent a couple of days out in the field collecting data, a couple of days processing and modelling that data, and then interpreting that data. We target kind of late-stage uni to early career people, so third years through to a couple of years working. And we have a competitive application process, so we're really targeting people who are wanting to know more about geophysics, but haven't had the opportunity to get much field geophysics training at university. We're entirely sponsor funded. We're kind of under the umbrella of the ASEG, and ASEG are our main financial sponsor. But we also have a lot of other sponsorship that comes from industry and government, and lots of in-kind support, especially in terms of people's time, but also donating equipment and vehicles and things like that. The labour for CAGE is entirely run on volunteer labour. So we have a convening team of sort of between 2 and 3 of us, depending on the year, and then a fantastic group of kind of demonstrators who are mostly people coming from industry, who come out and actually teach the techniques and those inversions. We've had a lot of great successes. There's certainly a lot of demand. We consistently have about 3 times as many applications as we have places. So there's certainly demand from students for this kind of training. We had great support from industry. It's hard work to get the sponsorship, but we always are able to get it as enough sponsorship to run the camp. We have great feedback from our participants. I could fill the whole talk with the nice things that they say, which is good. But also importantly, our volunteers obviously find it valuable as well. So they keep coming back each year, which is also a big success. The challenges are really around the sustainability of a course like that, and mostly around the volunteer labour. It's just a huge amount of volunteer labour that's required to run a camp like that. I think I probably spend between 2 and 3 months each year, a full-time equivalent, running CAGE. And it's, I love it and I get a lot out of it, but it makes it potentially an unsustainable program when it's so reliant on people's goodwill to be able to run it. Also, in the funding is also reliant on the goodwill of companies and organisations. Things have been okay so far, but if we were in a big downturn, then that funding would be harder to get. And I think a broader challenge is in the impact as well. Really being able to measure, we could have that great feedback from participants at the end of the camp, but really to be able to measure, are we meeting those goals of producing graduates with better skills going out into industry, is really challenging to measure. And that's one of our challenges at the moment, now that we've been running a few years, of how do we set up those processes to monitor whether we're meeting those goals. Just briefly to compare CAGE with Nexus. So Nexus is really the other, it's kind of the bigger sister or bigger brother to CAGE, and we certainly modelled ourselves off Nexus. Nexus has been running longer. This is the 10th year of Nexus. It's a bigger camp, 2 or 3 week camp in South Australia, and also a shorter roadshow in Perth. And Nexus aims to cover kind of mineral exploration more broadly, whereas we're just geophysics. But similar, that it also targets late stage uni to early career people, and again, a competitive application process, and again, lots and lots of demand from that cohort for this. So Nexus was initially kind of started or driven by funding from the Minerals Council. And that bigger cohort of that bigger amount of funding has meant that the coordinator of Nexus, which is Richard Lilly, has been able to have a salaried position. That Minerals Council funding has decreased over time, and now this year, my understanding is that there's no Minerals Council funding, and industry and government funding sources have filled in that gap.
2 minutes, Kate.
Sure. And that, just as Brendan talked about earlier, that Minerals Council funding has shifted more to this MIAX program that's targeting first years. But it's a shame that it couldn't have also continued for Nexus. And the other big postgraduate offering is obviously in master's courses and short courses that would be run through universities. And then this is more kind of your traditional university setting to run those training courses. That might range from a day to a full master's course that would run for a couple of years. To jump to kind of the summary, I think the big challenge with certainly with programs like CAGE and Nexus is their sustainability. To be able to plan for those programs, they have to be sustainable. There needs to be sufficient and consistent funding. And Nexus is a great example of this. Many of you may have seen Richard's post on LinkedIn yesterday, that this is the last year that he'll be running Nexus in its current form. And really because that funding has decreased and the structure of the university is changing. And it's just hasn't been sustainable to be able to continue on from now. And as I say, that's certainly our biggest challenge in CAGE as well. And I guess with that shift from, the old style where somebody would go to a university, the lecturer at that university would be paid because it's their job, and the student and the government would pay for that education. If we're now shifting to a model where industry is trying to fill those gaps, and so there's industry funding some of these training programs, but potentially people are not being paid for that work, it's a much less sustainable model. So I think as a community, if we think that that is a model that we're likely to continue, we need to figure out how to make it more sustainable. And also to look at the efficacy of those programs as well. I can't say enough how great I think it is to have some of these surveys coming out to really have quantified what are those gaps that need to be filled. So that if we're going to put all of this time and effort, there's only so much time and money out there that we can deliver programs that are filling those gaps and also measure them to make sure that we're achieving those goals. Thank you.
Excellent. Thank you so much, Kate. Really appreciate that talk. So our final talk in this session is going to take a somewhat different view, where we've been focused mostly on Australia, but the final presentation is by Dr. Christopher Keane, who is the Director of Geoscience, Professional and Higher Education for the American Geosciences Institute. So it will be really interesting to hear some of the initiatives that are going on elsewhere. So over to you, Chris.
Sure. Thank you very much. Appreciate the opportunity to talk to you about what big program that we've done here in the United States called Vision and Change, and then a few other things that we see that are currently emerging. So, I mean, get the sort of elephant out of the room. All of this is all of this is work that certainly is predicated on the situation before the new administration and the science enterprise. There's a lot of chaos going on right now in the U.S., and there's a lot of questions on the impacts on higher education and what that's going to potentially mean for our geoscience departments. But we actually think the reforms that I'm going to talk about may be actually an inoculation for the geosciences, but the key thing is that our programs are going to have to pivot hard. Otherwise, it will be a risk factor. So, I mean, one of the things, when we started this process is the reality is you looked at most U.S. geology curriculum, and most of it is built on a framework that dates back to the early 19th century. And they just stapled on some new ideas. And this was starting the divergence between what the industry needed in the workforce and what the universities are teaching. And one of the key things that we face, obviously the economic model is a little different here, is the fact that it is truly bums in the seats and how much they're paying. And one of the problems is the cost of university education has gotten so high that there's a great analysis that if you're a delivery driver for UPS and or you become a surgeon, you will have the same lifetime net earnings because of the extreme expense of pursuing education, higher degrees. So this becomes a decision factor for a lot of students. So interest in the topic is fine, but actually employability pathways are really top of the mind for a lot of students. But we do hear lots of concerns by employers about the preparation, their readiness for the workforce. As one said, particularly the graduate level, we're creating great scientists, they just don't know how to do anything. And so that's one of the key drivers. And then when we look, 92%, I mean, we have 300,000 geoscientists in the United States, 92% of whom work in the applied geosciences. And academia is extremely not applied. So there is this really big developing gulf between the education process and the workforce. So, what we are facing sort of on a macro level is we have this high consistent demand for geoscientists. We actually, the last quarter of last year, we had an increase of about 30,000 geoscientists jobs being created. I think we'll see a little bit of bumpiness here for the next 6 months. But this is also predicated on the problem. We have a very low supply. Our demographics are very poor for college-age students, and it is for the next 25 years. So our input is not going to grow. We actually have to steal students from other disciplines. And again, this extreme focus by students on employability. And so one of the things that about 10 years ago, this was becoming pretty evident to, I'd say, some of the big thought leaders in our community. And we realized there had to be a big reform. And so we were inspired by the biologists here in the United States. They did vision and change. But what they did in their university curriculum is they pivoted completely away from cellular biology to genetics-based teaching and the entire curriculum. And they did it as a community design process, not just within academia, but also in industry. And it's had great effect. Everyone's been very, very happy. Universities are happy, students are certainly better placed. And so basically the National Science Foundation said, hey, Geo, why don't you go ahead and try to do the same thing? And so we did take on this reform. Full credit to Sharon Mosier, who is dean at the Jackson School of Geosciences at the University of Texas. They are the proverbial 1,000-pound gorilla here in the U.S. But she is a great thought leader on this and helped drive this through. And one of the key things, even though our reform levels were not nearly as profound in this full pivot, but we did reframe a lot of the thinking. And part of that was the move from geology to Earth system science, but not to the softening of it. And I'll get to that in a minute. So we ended up having over 1,000 faculty, employers, university deans, and presidents. We held a whole bunch of summits to actually develop this process. And it is a collective vision of the community that was developed. So it is a sort of an organic buy-in process. What I'll get to is really the core thing. We had the same complaints that, as I heard in earlier talks, the courses and what do they mean, and they're smearing around and everything. And one of the core points was stop worrying about the courses. Let's start looking at the learning outcomes. And so like two schools, Virginia Tech and Appalachian State, who are just absolutely thriving right now, they did exactly that. They decomposed their entire curriculum from courses looking at the learning outcomes, did some horse trading between courses and made sure that the students actually were getting the full coverage versus worrying about what the titles of these courses were. Gave them a little bit more liberty to maybe make the title sexier or whatever, but they knew what was there and they could convey it to the employers. But what the key thing was, then we organized these learning outcomes around things like geoscience concepts, science skills, and geoscience skills. And the real key component here was the adoption of these individual professional development programs. The idea is from the very get-go, getting the student at the earliest point invested in their professional development and that they start tracking their skills. And so we were modeling after what we see in the oil and gas industry in Europe, where they, what they call, they do these tube maps and what is your professional progress, where are your holes, where do you want to get to, and what does that look like? It's all about establishing that dialogue for the students, both with faculty, and advisors, as well as folks in industry. And so when we looked at this, the geoscience concepts, again, sort of breaking out some of the traditional geology frameworks we had, these are all obvious to you, and I'm sure they all feel very, very soft, but these were really more organizations of a lot of very specific learning outcomes in each of these areas. But one of the big things within the U.S. education process was really getting the students to focus on Earth as a complex system and really getting their arms around deep time. Those were areas that had consistently been weak. The science skills, there was a whole slew, but really where we saw the biggest deficits that employers really wanted and the university faculty realized needed to get tackled was the development of critical thinking skills. This is something that has really largely been left off the table in our primary and secondary education. Building on the nascent talents of the students and really getting them to exercise that, and this integration of information from different sources, because one of the key things we have is our entire workforce is migrating into the professional services sector. So we're at about 54% of geoscientists work in the consulting field, and they're doing lots of diverse work. So the oil and gas and mining, those traditional industries are really not hiring like they used to. It's all been outsourced into this. But that's the key, is all these new professionals are working across a wide range of projects. So really making them much more literate and much more agile. The other big thing, we've done a lot of studies on this, U.S. students, their quantitative skills are absolutely atrocious. The one that always sticks out is the fact that only 63% of our PhD graduates had ever taken a stats course. When I show that to my colleagues in other fields, they just, shake their head. They're not sure how that works. And then the geoscience skills, again, looking at sort of subcomponents that they ended up identifying under this, working on spatial and temporal problems. There's been lots of good research at Texas A&M and now of a Cal Poly Humboldt, looking at innate spatial logic capacity of students and how you develop that. So there's lots of good bits of research that we're feeding in, but also, and I'm sure everyone here recognizes this is always the big challenge for the students, is working with uncertainty and the non-uniqueness. And one of the big things we're doing now is actually trying to introduce, what do geology work packages look like that you're going to deliver when you're actually a professional? And again, the strong computational skills was another thing that there was a lot of push. Our field skill survey results are exactly what you guys have shown. That's where the students report and the employers, it's very strong. And there's been a lot of investments to make sure we keep up with that. And the technological versatility is key. The students today are good users, not very good creators within the digital space. So looking at the adoption of the reforms, there was no financial support for departments to actually implement any of this. NSF funded the design, but they weren't going to make any additional investments on that. But most of our 700 geoscience degree granting programs here in the U.S. have actually taken on some level of adoption for reform. We have a feedback system to find out how they're doing and what they're doing, and about half have reported pretty strong failures. Usually things like faculty opposition, institutional mandates, or just lack of champion within departments. But what we have seen is when someone then picks it up and goes on a second effort, there's really great success at adoption. So those second pushes tend to be very good. And as I said, we have an increasing number of departments that have had high impact from taking this on. Like I said, Virginia Tech and Appalachian State are two, Utah State. These aren't necessarily the top level names you think of in geology in the US, but they're really actually producing great students. They're getting employed and vibrant and healthy departments in wowing their universities. And so I just want to wrap up looking at a couple other emerging models that we've run across. So one of the big things, and we're seeing this across a whole wide swath of areas here in the US, but we're also starting to see this now in the geosciences, this emergence of apprenticeships. We certainly hear lots of folks that, they'll hire a Gen Z and then fire them within a couple of weeks. It's just, they're not ready for work. But really, rather, the apprenticeship thought process here is to recruit the students out of secondary school or community college who are maybe showing the energy and the aptitude and interests, and a lot of just-in-time education on the geoscience as you train them up to be geotechs. And one of the key things is you get a couple of years with these students, and most of the employers have some kind of education benefit for their students. Or I'm sorry, for their employees. So this actually puts the student that was brought on as an apprentice in a position to have the employer end up covering the cost of their geology or engineering degree, whatever is most appropriate. And that's pretty much a life changer. That opens up to a very large population that we would traditionally not see go into higher education either. So this is growing. I'm hoping the Trump administration keeps some of the efforts that the Department of Labor was trying to push through on some of these as well. The other, which I found fascinating, was in Brazil. They've taken on what basically is a residency model after the medical industry. Their industry and their surveys and groups have basically given up on trying to get the university programs to sort of develop the skills the students needed, but recognized they were doing a really good job. They knew their content, they knew the science, they were good scientists, but they didn't necessarily know how to do anything, sort of like the complaint we had. So this model basically gives the students these 2-year paid, not very well, but paid, livable wage appointments through the Geological Survey, and they get an opportunity to work across the Geological Survey, get a broad set of experience, develop a whole bunch of skills. And what's interesting is that they worked with a couple of the universities, and the folks that finished that and have sort of a culminating project that they have to present and get evaluated, they actually get a master's degree awarded for this experience. And then they're out on the job market. But at that point, because they've been working through the survey, they often already have pending job offers, whether in the survey or in a number of the other companies that they have been intervening in. So find that as a really, really fascinating sort of command control model, but certainly something that is worth looking at. We have similar things going on in other industries like aviation here in the United States. It's not unheard of, and we've been having conversations like with the Defense Department and the like about that, particularly for minerals workforce.
1 minute, Chris.
Yep. So that's the wrap. So this URL, QR code, will take you to the Vision and Change website. The full report is available there, and contact information, and feel free to reach out to me. Happy to talk to anyone about that experience and some of the details and the like. The report's about 240 pages, so plenty to chew on there. So I appreciate it.
Wonderful. Thank you so much, Chris. Very, very informative. Before I hand over to Ned for a discussion about where to now for the AIG Education Committee, I'd just like to, on behalf of everybody, thank all of the presenters today for taking the time to present and do the research that generated the really informative information that was presented today. Over to you, Ned.
Great, thanks very much, Mark. I'll just share my screen again. All right, so I'm just going to give a little bit of a wrap up and particularly talk a little bit about the planned next steps to give some context around why we've actually run this workshop, this webinar in the first place. So firstly, I'd just like to say, I think it's been a fantastic session. It's been wonderful to be able to get this diverse lineup of people to contribute to, better informing the geological community, the geoscience community on what the nature of the issues are, where the commonalities are, where the gaps are, and some of the possible solutions. So thanks again very much for all those people who've volunteered their time and contributed to that. So this, the idea for this webinar originally came out of basically a set the stage information session for a Geoscience Education Action Plan workshop that the AIG Education Committee has committed to. But we thought, well, there's lots of people out there who are interested in this issue, so let's make it publicly available so we can lift the overall kind of and breadth of understanding of the issues across the community. So as part of that, we are looking to run a geoscience education workshop. The aim of this is to define a 5-year action plan for how the AIG can support geoscience education in Australia. So as part of that, we're involving about 16 people in that, which is about as many people as we can before things get difficult in terms of coming up with an actual action plan. It's involving people from the AIG Education Committee, the Professional Development Committee, and a whole host of people representing different interest groups who can contribute their understanding and perspectives to the discussion, from universities, from industry, school educators, students, and recent graduates. So what we are aiming to do with this action plan, with the workshop, is to come up with that action plan focused on 3 key areas, one being schools, then tertiary education, and then ongoing professional development. So we're tackling it in those 3 themes. We're going to do that via a few online sessions that in people's own time on Saturdays during the next few weekends in February and early March. And so out of that, we intend to come up with an action plan for how the AIG can support geoscience education to put to the AIG board for consideration to act on that and fund that. We are also already through the planning process exploring collaboration opportunities with other representative bodies as well. We see this as very much an issue that unites a lot of us, and it's a real common cause. And so, realizing the potential to upscale and coordinate our action across different representative groups and stakeholders in the issue, I think is a really key thing that we are looking to pursue through this. So if you're a member of other representative bodies and you're interested in collaborating with us on that, please get in contact. And finally, I thank you very much to the presenters who volunteered their time and contributed to the discussion today. To the attendees, I think we had about 100 people turn up, a bit over 220 registrants. So thanks very much for spending your time to come along and learn more. And in particular as well to the people who are going to be contributing and participating in the workshops. There's a lot of people dedicating a lot of time to building this to make it the best plan we can. Please complete the online feedback form or send an email around to all the registrants after, but that is the link there. It's also in the chat. So we've just got in lieu of being able to have a discussive session, which just isn't practical for a webinar like this, we've put together a feedback and contribution form. So we really welcome everyone's contribution via that. Their perspectives, not just on the webinar and where the issues are in geoscience education, but also, what they would like to see most that the AIG tackle through this. Also, the presentations and recordings of this will be made available as well on the AIG website and YouTube, so that they'll be there as a reference for everyone going forward. Thank you all very much. Really appreciate it, and I'll hand back to Mark.
Thank you very much, Ned. And final reiteration to everyone, thank you very much. And I hope you've found this particular session to be enlightening and interesting, and really appreciate the various contributions. So enjoy the rest of your day, no matter where you are in the world, and thank you very much for your attendance. Goodbye.